The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
You're back with David Mackey's Shiny Side Out on freedomslips.com, on the #1 listener-supported talk radio on the net. So push the donate button or subscribe to the archives for only about $5 a month via Patreon. Also, get yourself some great merchandise from the station's website. Maybe you could buy a CD. This is a way to support the channel. You can buy a CD. You can, maybe get an EMP-proof thumb drive. You can get seed packs. There's a whole bunch of things. But, make sure you understand your importation laws if you live outside the US, because in Australia we have actually some pretty good quarantine measures when it comes to natural produce. We'd like to keep our country devoid of, insects and mold and other things that plague the Northern Hemisphere or all the other countries. So, we've got an idealistic view, but look, we maintain it through some good quarantine there. So understand what that means. And, you can't buy, I think it's like a large hunting knife or something. There's some restrictions about what you can and can't bring into the country here. So look, understand what they mean to you, and let's move on. So, thanks for listening also to Revolution Radio. And this is David Mackey's Shiny Side Out. Nearly 10 years. This is show number 489.
980 and 400. I mistakenly thought it was 490, but yeah, time does fly.
It's still flying.
It's still flying.
And it's relational to how fast you're going.
It is certainly.
So you've been going real fast. Actually, no, you've been slowed down.
I'm going nowhere real quick.
According to relativity, you slowed down a little bit. That's right.
That's what happened. Now, so look, he's trying to with the shoe on. With a hammer. He's trying to segue us into the show's topic today, which is the rational and logical approach to the UFO, or as it's called now, the UAP phenomenon. Now, a couple of things to say. Part 2, yeah. A couple of things before we launch into it. The overarching theme here is this. The universe is very large. I know. Thank you, Captain Obvious, you'll say. And it has trillions and trillions, and in fact, we don't even know how many suns it has and planets and potential life thereon. However, on our planet, we have been exposed to a certain phenomena and certain strange things, right? I mean, certainly the UFO phenomenon, which is now called the UAP phenomenon. So we used to call them unidentified flying objects. Now we're calling them unidentified aerial phenomena. Now, the reason for that is very simple, and we'll get to in maybe not today, but I've written in these show notes. I've written more than I've ever written for any show notes. The point is that people out there cannot acknowledge that the UFO phenomenon is real. They cannot, even though it is the UFO phenomenon. It's completely real. Okay, and it's been acknowledged. The Tic Tac. It was probably the Nimitz footage. The Tic Tac footage was the straw that broke the camel's back. Yeah. But for literally decades, they've said no, it's all nonsense. It's weather balloons. It's low flying geese. It's swamp gas. It's everything
Venus.
but what. Yeah, exactly. It's everything but what you think it is. And now they're saying, oh, you know what? Now there is something, and we don't know what it is. It is not a weather balloon. It's not Venus. It's not low-flying geese. It's none of that. We don't know what it is. But we can't now say, oh, it's UFOs. No. They're UAPs. It seems as though it's a new thing, right? It's a new phenomenon. It's UAPs. No. Let's be very clear. It's the same phenomenon, just called something else. Remember how we talked about people liking to call things, certain things? Because then they're dealt with it. So now it's called an unidentified aerial phenomenon. Same thing as before. The problem here that I see, and I think Dave happy for you to disagree on this. The problem that I have with the whole phenomenon, and let's be very clear, this has been with us for thousands of years,
Mm-hmm.
and it reaches well into our prehistory, so longer than thousands of years potentially, and this is the problem. And we talked about the size of the universe and what kind of civilizations could exist, and Fermi's paradox is saying, oh, where's everybody, right? Drake's equation, which tries to estimate how many civilizations should be out there, which is, of course, complete nonsense, because we have no idea what the parameters are. We only know our solar system, and not even that well.
So, and remember, it's an anthropomorphic.
Anthropomorphic, yeah, 100%.
That's what we're doing. We're applying our reality on theirs, but aliens could take any form.
Bingo. And the problem here is naturally that all the aliens that we seem to come across, all the extraterrestrials that we seem to interact with, and I'm not saying we're not, seem to be of human proportions or by symmetrical, arms, legs, head, even though large eyes, or they might be, seemingly reptilian.
But they're still, two arm, two leg, eyes in the head and pointing forward above a mouth and a nose.
Yeah, so very specific to our biology. Okay.
Yeah.
Now, ultimately, I'm not saying that isn't the case. Not at all. In fact, I very much think that it is. What I don't think is happening, that a true extraterrestrial, like a life form that evolved or came about on another planet other than ours on its own, right? It would not be anything like us. It's highly unlikely that it would be anything like us. It could certainly not interbreed with us, even on this planet. Right, where we're all cousins, really. If you think about it from a DNA point of view, a horse and a donkey can have offspring, right? They're very closely related animals, but their offspring is going to be sterile. Right?
It's a mule.
It's a mule. And similarly, we know now that we have interbred with Neanderthal and Denisovans, etc., etc. Therefore, they are not a different species of.
We did it successfully.
Yeah. With offspring, so we know, because their DNA material is in us. There is no line of DNA, that there's no animal in the world that, except for a mule, but no further generations of that contains both horse and donkey DNA. It doesn't exist except for the mule. So here we are. This is simple biology, right? Now, so there are a number of things to consider. Number one, there was a massive seeding event at some point in the past which seeded all life in the galaxy, for argument's sake, right? Star Trek dealt with that. You can watch the episode if you want to. Is that possible? Absolutely. Absolutely, it's possible. In that case, the mystery is even deeper and much further reaching into the past than we can even imagine. So a seeding event is possible. I'm not talking about just some cosmic spores. I'm talking about directed seeding of specific DNA. Okay.
The Star Trek episode also said when they all become friends and they all interbreed, the unique race would get created.
Correct, and it'll all be rainbows and lollipops, right? And rainbows, in fact, rainbows farting lollipops. That's what happened. But the point here is that we again that could be. But let's park it for a second.
Yeah.
And then the thing that I think is actually happening is that all these interactions we're having with these beings, as it were, are in fact with beings that are here. They're all here. All of them are here. Maybe several different races, not species, not other creatures, but creatures that can interbreed with us. So ancestors of ours, if you will, or contemporaries, I don't really care which way you make it, but all of our ancient legends, and we're going to talk about that in detail as well, talk about us being made, right? It goes right back to the Anunnaki, etc., etc. To labor, essentially, to toil. That was our purpose. And we were made in the image of the so-called gods. And so these beings are still here. They're still here. We contend, and they're still underground, under the ocean, etc. They've got technology far beyond ours. But another thing that is very clear, and we're going to go into some detail, is that their technology is stagnant. It hasn't changed in thousands of years because the same things are being described. They also do the same things over and over, like cattle mutilation, for example. Right? That's happening everywhere. And there's a really fantastic article just this month published in Australia, Dave, around cattle mutilation, which we have as part of the show notes to go into some detail there, because it's important in the context. So all of these interactions that we have with these beings, I don't think they have very far to travel at all. Now, could they? Absolutely they could. But in order to interbreed with them, in fact, in order to have any interest in continued cattle mutilation or anything of that nature, you'd have to ask yourself why. Why would you do that? It makes no sense, but we'll talk about that in detail as well. So the contention here is that the Fermi paradox is asking the wrong question. Where is everybody? Rather, they should ask, where are they all, and why aren't we looking in the right places? Right? That should be the question. Why aren't we looking in the right places? Right here under our noses, right? That's where they are. They're all here. And potentially galaxy faring, and potentially, all around, traveling out into space. And we are not included in that because we are the poor
primitive.
We're the surface dwellers. We're the developing world as far as they're concerned. I mean, there are examples of that. There's the famous cargo cult example of World War II. So what happened in World War II? American pilots specifically went to the Pacific Islands to set up landing strips and supply dumps, etc., etc. And the natives interacted with these Americans, right? They were quite primitive. They were not as advanced as we were. At the time.
So Becky, if you're an islander who's never seen any technology at all, suddenly a metal bird lands and a guy there who can command fire from his lighter, his Zippo, and then breathe smoke by smoking a cigarette, in a plane that made a hell of a noise when it came in, right?
And
in a leather jacket, because an islander didn't have leather; they had fish, right? So all of that is such a departure from what their world is, and their ability to have words to describe their world. That was so vastly different that they decided what they were going to do because the Americans, left again, right? So they built their runways and had food and everything. They repaired their planes and they disappeared.
Yep.
And then on that date, what did they do?
But see,
anniversary date.
They did build these runways and weather vanes and all that, but they did it to bring them back. Right, they did it to bring because they had received chocolate or other benefits from the Americans being there, like the tools, etc., etc. So they wanted the gods to come back, so they built all these things, like Dave has pointed out. Right,
they would build a wicker copy of the plane.
Yeah, yep, absolutely.
On the date, on the anniversary.
And the reason we know that is because anthropologists went to study the Pacific Islanders, and they found this, and they called it the cargo cult, right? Because they had received all the stuff, and they, all of a sudden these gods or these superior beings disappeared, and with it disappeared chocolate and maybe Coca-Cola or whatever. I don't know, right? But the point is they tried to bring it back. So it's not alien, pardon the pun here, to our nature to do these things. If thousands, tens of thousands, hundreds of thousands of years ago, advanced civilization existed on the Earth, and I believe very firmly that they did. There's certainly the Atlantis civilization, and I don't care what you call it, and there's the Lemuria civilization, and there's also the civilization from the Indus Valley, right? And people believe that they were at war with each other. Some of these, right? It's possible, but whatever. It's neither here nor there. But then something happened. There was a catastrophic event. Whatever might have happened, who knows? And it destroyed large tracts of it, and maybe at that point those civilizations decided to go underground. It's stupid to live on the surface of the planet. Let's live under the planet. And then, whoever emerged on top, the survivors, as it were, they eked out a living for themselves, maybe under the supervision of the, bottom or, the below dwellers, but certainly, on their own for most part. And additionally to that, and we'll talk about that as well, is the extreme longevity that is associated with those that went before us, those civilizations that seem to have achieved lifetimes in the tens, if not hundreds of thousands of years. Now, this is probably where you go, you're crazy, Mackie, that's just nonsense. It's not. It is not at all. And we're going to talk about telomeres and telomerase as well, and we will certainly talk about that in show number 500. But the point is, we are living on a planet that seems to have a lot of strange phenomena, very concentrated in certain areas, interacting with beings that are very much like us, that we can seemingly interbreed with, beings that have an interest in our livestock, continued interest, things we cannot explain, unidentified aerial phenomena, UFOs for you and me, that are real. We know they're real. And none of it makes sense if we are truly talking about voyages of light years, maybe, intergalactic voyages, etc., to the extent that we still experience over thousands of years. It makes perfect sense, though, if those civilizations exist here with us still. And they seem, like I said, they seem to be static because they haven't changed their technology, seemingly. It's the same tech they used 5,000 years ago, they're still using. It's the same stuff. I wouldn't be surprised if the craft, and maybe that's what they are, that we're seeing are the same craft that were seen by Noah or Gilgamesh or whoever.
Yes, absolutely.
Maybe with the same pilots inside, is my point.
Mm-hmm.
Okay? So that's the platform from which the show cycle approaches this, right? And I'm looking at the rational and logical approach because it's the only way I can, by looking at the size of the universe, by looking at what kind of civilizations could exist within it. And again, Fermi is asking the wrong question, and the Drake equation, is, as far as I'm concerned, is a complete waste of time. Now, Fermi says, where is everybody? Okay. Now, I think any galactic civilization that exists out there, type 1, type 2, or type 3, and we went into some detail. This is, by the way, the scale that was invented in 1964 by Nikolai Kardashev, and he was a Russian astrophysicist. They probably wouldn't know what to make of our radio signals. We are so primitive, I believe, in comparison to a type 1, 2, or 3 civilization that, ants. You know ants are there. There's a beautiful example.
I love that Michio Kaku discussion.
Yeah. But I mean, ants, they are aware of our presence. Like, some of us might step on them once in a while, but they could never understand the nature of humans, really. I mean, they understand there are things there, but they can't glean an understanding of what motivates us, what drives us. The ants cannot understand, I think, the nature of our civilization. As in a similar way, we are the ants now. We could not understand a galactic civilization that could potentially build suns, harness the energy of black holes. Right, that's what we're talking about now. Right, this is the level of control.
Yeah, and I'm gonna also add. This is the quote from Michio Kaku. He says that the humans don't expect to have a meaningful conversation with an ant. That's one of the points that he makes.
Yeah.
So you step out your front door, you don't go, "Oh, hey ants, how are you?" and they talk back, right? Mm-hmm. That isn't something that happens. It isn't a thing. We never thought that it's going to be possible. And therefore, we should also make the same assumption about aliens. Now, one thing that comes up all the time is the prime directive from Star Trek. It was theorized, Gene Roddenberry put that together as a great concept, saying there should be a level of governance around first contact with a civilization. If you're spacefaring, wait till they come out in space. So it's the rule is broken a number of times within the Star Trek universe, but also you could say the same rules have been broken here. They're not here now, but maybe it's okay to visit a planet with a primitive race and go, you know what, farming's a good thing, right? Try some farming. Have a governance of people. And stay away from fractional reserve lending. No one ever listens to that.
But take it a step further. And then I completely agree with the point you're making. But think about it this way. So we go out into space and we do it with machines, right? Mm-hmm. We go out there, we go to planets. We have machines that would help us maybe terraform a planet, turn it into like a second Earth, whatever it might be. Mm-hmm. Now think about it this way.
Make it comfortable. Turn the air conditioning on.
Mm-hmm. Yeah. So but let's say for argument's sake, right? There were a race of extraterrestrials that came up on the Earth millions of years ago, for argument's sake, or hundreds of thousands of years ago, whatever it is, right? And life had developed a certain way here, and they found, oh, geez, this life is very slim to us. Or alternatively, there was a seeding event, and they were part of it, and they just developed faster than we did. And here they are, and they did all the work, which we know they did, and they built, they dug the rivers of Tigris and Euphrates, and they go, oh, we don't want to do this work anymore. So what they did then, they created us, if you will, not out of clay and whatnot, but out of their own genetic material plus local things that might be there that might be useful, right? Mm-hmm. And the thing is this. Let's say, but even if this civilization had evolved here and developed on the Earth independently here, like before us, and then a catastrophe wiped some of them out, they might still have used that genetic cloning or whatever technology to create a worker race, because there might not have been that many of them left. Now, we wouldn't be as good as they are, I guess, because there would be limitations built into us, like death and aging, right, which they might have long since eliminated. But that's all we're seeing. This is exactly what we're seeing. We're seeing these legends that tell us, oh, you shouldn't eat from that tree. If you eat from that tree, we're going to kick you out of the Garden of Eden. And you know what tree that was? It wasn't the tree of knowledge. It was the tree of life. We were warned not to eat from the tree of knowledge, but the reason we were kicked out of the Garden of Eden in the Bible was because we were threatening, or we were in danger of eating from the tree of life. And if we had done that also in the Bible, interestingly enough, we would become like them, like God. So we had the knowledge and life.
The limit of 120 is mentioned in which text?
That is in the Genesis.
That's right. Now, the people who made, notated Genesis would have zero understanding of genetics. I'm just going to put that out there. So that message is actually quite true. We are limited to 120 years of age as an amount of time that our cells can replicate until we can no longer function. That limit was intentionally built in so that we don't live forever, because the stories of the antediluvian life, the pre-flood life, was that we live forever, for exceedingly long periods of time. And the flood wiped all those people out and they created life again. So probably, and it was, different cultures have different description of it. Certainly there's a lot of cultures in the world where beings showed up. Star people is one mention. The other is maybe the Dogon tribe, if we all remember them. I was reminded of them a couple of hours ago in a conversation I was having with the local UFO community that I'm involved in. One thing really interesting about them is they mentioned a star of the origin of these people, which we can't see with the naked eye. Their story is the second sun in that star system, which is only infrared light. Can't see it.
Binary, we only discovered this binary system fairly recently. So that's absolutely correct.
So Sirius too, and we can't see it with the naked eye, except they've drawn it and it's proportionally correct. The artistic representation is the real representation. It's proportional. And they, point at the sky, at it, and say that's where they said they came from, but not the one we can see. It's the second one. Mm-hmm. How would they even know there was a second one if it wasn't true? So this messaging and being able to contact primitive society before you get tech, because once you get tech, you show them advanced tech, you kind of work towards it.
Completely. This is really so, Ben. None of this contradicts our position where we say these can't be truly extraterrestrials, because then none of the activities, none of the things we see happening here make any sense. Mm-hmm. None of them, and especially the prolonged nature of these activities. They have over thousands of years, clearly interfering. Forget the first, the Prime Directive. Forget that. Clearly interfering in our development and history numerous times, in fact, right? And Ezekiel, I don't know if you noticed, he never came back. He was taken up into the sky. He never came back. So, but I do believe very strongly that
he left his clothes behind, oddly.
Yeah, it's funny, right? We see this as well with some of the park disappearances. And we always, funny thing as well is this UFO, UAP activity, what you call it these days, is also accompanied by Bigfoot sightings and other phenomena like we see in the Skinwalker
There you
Ranch.
go, nobody, we mentioned it.
That's right. But this is, and I urge everybody to watch the second season of the Skinwalker Ranch. Very, very. Anyway, you do what you need to do. But ultimately, okay, and I really am very passionate about this because it is a real phenomenon. It's a real thing. We can now. I mean, I always believed it was real, but now the official stories. Oh, it is real. Oh, geez, look at that. And and all all the misinformation and all the other things that have been put in our way to detract us, the red herrings, hopefully we can peel some of them away. But the true story of our race is a complete mystery. Okay, the true story. All I know is that's what's happening right now is not part of a larger plan to keep us ignorant of our true nature. That's what this pandemic is designed to do, in part. So anyway, so here we are. We are sharing the planet with clearly much older civilizations, right? Because the thing is this, I mean, biological life, and this is where we're going to hook into today's show, but we needed this little preamble. Biological life doesn't have to take our route, our form. We have red blood. Yeah, red blood where the oxygen-carrying molecule is iron. So it's iron because it oxidizes easily and it carries the oxygen in our body. That's why our blood is red. The blood of an octopus or of a lobster is blue,
and it's
copper. Right,
and that's why scientists have suggested that there isn't a progenitor for the octopus, and that it's in fact determined that it's entirely foreign to the planet. It must have arrived here.
Yeah. And it might have, right? It might have, who knows? I mean, like I said, this planet has been not at the center, but certainly part of intergalactic travel, well, let's call it galactic travel, for quite some time, right? And holy moly.
Remember Tiamat, the Sumerian discussion.
Yeah, absolutely.
So Tiamat was collided by another planet, and the waters mixed. You read the Sumerian texts, and they talk about this.
Yeah. And this goes back thousands of years. So these cuneiform tablets are about 5,000-6,000 years in our past, and some of the earliest surviving written records that we have. And this is really how far our knowledge goes. Like, if we are stretching ourselves, Dave, I mean, really stretching ourselves, 10,000 years. That's why Göbekli Tepe was such a surprise, came out of nowhere, like 13,000 years old. Who built this? Oh, some farmers, they worshipped something. Okay. Complete nonsense, in my opinion. And then you've got the other ruins that exist in South America, elsewhere in the world. Africa is action-packed with ruins that are predating known history. But
the
let's
ring
look at
stones,
this.
Becky.
Oh, what it's all connected, and you can't make sense of where we live today unless you understand all of it. And now, but let's talk quickly about this new study that estimates the odds of life and intelligence emerging beyond our planet. This is a study from 2020 by the Columbia University. I'll give you the summary, and then Dave will take you through.
Go for it.
The rest of it. But essentially, the summary is this: despite knowing when life first appeared on Earth, scientists still do not understand how life occurred. We don't understand it, which has important implications for the likelihood of finding life elsewhere in the universe. Now, I want to stress here, life as we understand it. A new paper shows how an analysis using a statistical technique called Bayesian inference could shed light on how complex extraterrestrial life might evolve in alien worlds. Dave?
Humans have been wondering whether we're alone in the universe since antiquity. We know from the geological record that life started relatively quickly as soon as our planet's environment was stable enough to support life. We also know that the first multicellular organism, which eventually produced today's technological civilization, took far longer to evolve, approximately 4 billion years. But despite knowing when life first appeared on Earth, scientists still do not understand how life occurred, which has important implications for the likelihood of finding life elsewhere in the universe. In a new paper published in the Proceeding of the National Academy of Sciences today, David Kipping, an assistant professor in Columbia's Department of Astronomy, shows how an analysis using a statistical technique called Bayesian inference could shed light on how complex extraterrestrial life might evolve in alien worlds. He is quoted as saying, "The rapid emergence of life and the late evolution of humanity in the context of the timeline of evolution are certainly suggestive, Kipping said. But he continues, but in this study, it's possible to actually quantify what the facts tell us. To conduct his analysis, Kipping used the chronology of the earliest evidence for life and the evolution of humanity. He asked how often we would expect life and intelligence to re-emerge if Earth's history were to repeat, rerunning the clock over and over again. He framed the problem in terms of our 4 possible answers. Life is common and often develops intelligence. Life is rare but often develops intelligence. Life is common and rarely develops intelligence. And finally, life is rare and rarely develops intelligence. So, this method of Bayesian statistical inference used to update the probability for a hypothesis as evidence or information becomes available, states prior beliefs about the system being modelled, which are then combined with data to cast probabilities of outcomes. The technique is akin to betting odds, Kipping said. It encourages the repeated testing of new evidence against our position. In essence, a positive feedback loop of refining your estimates of likelihood of an event. From these 4 hypotheses, Kipping used Bayesian mathematical formulas to weigh the models against one another. In Bayesian inference, prior probability distributions always need to be selected, Kipping said. But a key result here is that when one compares the rare life versus common life scenarios, the common life scenario is always at least 9 times more likely than the rare one. The analysis is based on evidence that life emerged within 300 million years of the formation of Earth's oceans, as found in carbon-13 depleted zircon deposits. And zircon's you might know that as a very diamond-like crystal. A very fast start in the context of Earth's lifetime. Kipping emphasizes that the ratio is at least 9-1 or higher, depending on the true value of how often intelligence develops. Kipping's conclusion is that if planets with similar conditions and other evolutionary timelines to Earth are common, then the analysis suggests that life should have little problem spontaneously emerging on other planets. And what are the odds of that these extraterrestrial lives could be complex, differentiated with intelligence? Here, Kipping's inquiry is less assured, finding that only 3-2 odds in favour of intelligent life. This result stems from humanity's relatively late appearance in Earth's habitable window, suggesting that its development was neither an easy nor an ensured process. He says, if we played Earth's history again, the emergence of intelligence is actually somewhat unlikely, he said. Kipping points out that the odds in the study aren't overwhelming, being quite close to 50-50, and the findings should be treated as no more than a gentle nudge towards a hypothesis. He says the analysis can't provide certainties or guarantees, only statistical probabilities based on what happened here on Earth, Kipling said. Yet, encouragingly, the case for a universe teeming with life emerges as the favoured bet. The search for intelligent life in worlds beyond Earth should be by no means discouraged.
And you know what I love about this Kipping fella is completely truthful, honest. He doesn't try to browbeat us with his theories and findings and says, look, this is what Bayesian inference maths tells us.
Mhm.
You know, but looking, and he said this very clearly, based on what happened here on Earth. And again, we have no idea what happens on other planets. We have
Mhm.
no idea. We can only everything we know, and it's precious little at that. We know because we're here on Earth. That's what we know. And I really like the way this was put. But even with what we know here on Earth, and even using all of these statistical methods, life is the more likely outcome, right?
Mm.
Because life on this planet specifically happened fairly quickly, right? Intelligent life, again, see, I believe that intelligent life is a lot older than we are generally led to believe by the general accepted scientific community.
Mhm, mhm.
Not necessarily, Homo sapiens, but certainly maybe our forebears, maybe the reptilian races that, or dinosaur races that branched out of the dinosaurs, the large
Mhm.
dinosaurs. Because the dinosaurs, make no mistake, they were on this planet for tens of millions of years. I
Yeah.
find it astounding that no intelligence developed there. I'm not saying that it had to, but I'm just finding it astounding that it didn't.
And we're not saying it didn't.
Yeah.
Because remember
Exactly.
NASA, what NASA did? They did a study into what would the life have looked like if it emerged to be bipedal.
Yeah.
And they spent millions, right? And they turned out to make a human, a version of a dinosaur and what it would look like, what its eyes would look like, what its skin would be like.
Yeah.
And it was a little bit more reptilian, kind of amphibious than human. But, I think that's some extraordinary research that was taken because they took that seriously. Thinking about, a 30 million year period of time where you could be anything. And the only reason we know about dinosaurs is from fossil records, and we've not got that kind of right, and it's evolved over time. There's no reason to say that they didn't. Because if
Right.
you look at the human record of existence on the planet and what we would eventually leave behind and what would be there in 65 million years from now, there'd be very little. All of that technology would have disappeared. Right?
But
There
we
would be
have
nothing
found-
left behind except for some bones in the likely case that they weren't destroyed in some future cataclysm.
But we have found evidence of intelligence reaching into massive antiquity. Like we're talking 100 million years now, right?
Mhm.
We have found this in mine shafts. We have found it embedded in coal.
Mhm.
Now it's discredited or disregarded by mainstream science because it doesn't make any sense in the greater narrative. Doesn't mean it's not true. And
If it doesn't
show
fit,
this.
if it doesn't fit the narrative, it's thrown into a big pile, and the
Yeah.
pile's massive.
Yeah, that's right. And so once in a while, the single items from the pile re-emerge and are re-evaluated, and by maybe brave or scientists that just don't care about tenure.
Courageous.
But that's what it is, though. But let's be clear. Like, I mean, again, we are working with what we know, and again, I maintain that certainly we have been around a lot longer maybe in different shapes and forms than we know for now, and I believe very strongly that there were precursors to us on this planet as well. I believe that very strongly, and they might still be around. Funnily enough, Doctor Who as well as Star Trek have delved into the matter and talk of the Saurian races that.
That's right, Saurians. That's right.
Preceded us. But let's talk about other life now and the biochemical basis for it. Now, life on Earth requires water as a solvent, in which biochemical reactions take place. Sufficient quantities of carbon and other elements along with water might enable the formation of living organisms on terrestrial planets, planets that are like Earth, with a chemical makeup and temperature range similar to that of Earth. But again, it's Earth-like life, right? Life based on ammonia rather than water, for example, has been suggested as an alternative, though this solvent appears less suitable than water. It is also conceivable that there are life forms or forms of life whose solvent is a liquid hydrocarbon, such as methane, ethane, or propane.
Those planets, Mackie, exist in our outer solar system.
Yeah, absolutely. 100%. I mean, they might be teeming with life that we simply wouldn't recognize as such, though, right? About 29 chemical elements play active roles in living organisms on Earth. on Earth. About 95% of living matter is built upon only 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These 6 elements form the basic building blocks of virtually all life on Earth, whereas most of the remaining elements are found only in trace amounts. The unique characteristics of carbon make it unlikely that it could be replaced, even on another planet, to generate the biochemistry necessary for life as we know it. That's my edit. The carbon atom has the unique ability to make 4 strong chemical bonds with other atoms, including other carbon atoms. These covalent bonds have a direction in space, so that carbon atoms can form the skeletons of complex 3-dimensional structures with definite architectures such as nucleic acids and proteins. Carbon forms more compounds than all other elements combined. The great versatility of the carbon atom and its abundance in the visible universe makes it the element most likely to provide the basis, even exotic ones, for the chemical composition of life on other planets, Dave.
Yeah. So there's another element that isn't mentioned there yet, and we might get to it, but sand. Becky.
Yep.
Silicon.
Silicon.
Yeah.
Yep.
So silicon has also been suggested by science as an alternate to carbon. It's very similar, and its structure would also lend itself to being able to do that same function. So, but what do we find? Scientific search. The scientific search for extraterrestrial life is being carried out both directly and indirectly. As of September 2017, 3,667 exoplanets in 2,747 systems have been identified, and other planets and moons in our own system hold the potential for hosting primitive life such as microorganisms. As of 8th of February 2021, this year, an updated status of studies considering the possible detection of life forms on Venus, believe it or not, in the atmosphere via phosphine, and Mars via methane was reported, because they are outputs of combining elements together that would be an organic process. Does it make sense? I hope it makes sense to you. On Earth, all known living things have carbon-based structure and system. Scientists have speculated about the pros and cons of using atoms and other than carbon to form, I didn't know we were going to get to there, form the molecular structures necessary for life, but no one has proposed a theory employing such atoms to form all the necessary structures. However, as Carl Sagan argued, it is very difficult to be certain whether a statement that applies to all life on Earth will turn out to apply to all life throughout the universe. Sagan used the term carbon chauvinism for such an assumption. He regarded silicon, there you go, and germanium. And we use germanium, actually, if you don't know, we use that in night vision goggles.
It's a rare earth element. Yeah, absolutely.
Yeah. It isn't from your germanium. From your geraniums. Germanium is not from geraniums. And look, it's conceivable alternatives to carbon. Other plausible elements include, but are not limited to, palladium and titanium. But on the other hand, he noted that carbon does not seem more chemically versatile and is more abundant in carbon does seem more chemically versatile and is more abundant in the cosmos. If you came across someone that was structured on titanium, I can only imagine how impossibly strong they'd be. Because that's a very strong bond. Very light too. Norman Horowitz devised the experiments to determine whether life might exist on Mars that were carried out by the Viking lander in 1976, the first US mission to successfully, there's a filter and a half, land an unmanned probe on the Mars surface. Horowitz argued that the great versatility of the carbon atom makes it the element most likely to provide solutions even exotic solutions to the problem of survival on other planets. He considered that there was only a remote possibility that non-carbon life forms could exist with genetic information systems capable of self-replication and the ability to evolve and adapt.
Absolutely. Which brings us to the hypothetical types of biochemistry. The term carbon chauvinism is probably one of my favorite terms ever, because it does describe our mindset perfectly. I'm a carbon chauvinist. And hypothetical types of biochemistry are forms of biochemistry agreed to be scientifically viable, but not proven to exist at this time. The kinds of living organisms currently known on Earth, as we've just outlined, all use carbon compounds for basic structural and metabolic functions, water as a solvent, and DNA or RNA to define and control their form. If life exists on other planets or moons, it may be chemically similar, though it is also possible that there are organisms with quite different chemistries. For instance, involving other classes of carbon compounds, compounds of another element, or another solvent in place of water. The possibility of life forms being based on alternative biochemistries is the topic of an ongoing scientific discussion, informed by what is known about extraterrestrial environments and about the chemical behavior of various elements and compounds. It is of interest in synthetic biology and is also a common subject, of course, in science fiction. The element silicon, as Dave has pointed out, it has been much discussed as a hypothetical alternative to carbon. Silicon is in the same group as carbon on the periodic table, and like carbon, is tetravalent, so it can form 5 tetra. Anyway, I have to get the number right. Hypothetical alternatives to water include ammonia, which, like water, is a polar molecule and cosmically abundant as well, and non-polar hydrocarbon solvents such as methane and ethane, which are known to exist in liquid form on the surface of Titan.
And the number is 4, Mekhi.
It's 4. That's what I thought. 4, right? Yeah, good. I was right the first time.
Always were right the first time.
Always stick with your first answer. Now, the next component here in our discourse is something that Dave and I discussed, in fact, with a friend from work. And I put it in here because it does fit into the overall understanding of the universe. So, Dave, this is all you, my friend. I think, we might be able to get through it. And if not, that's okay. We start with it again next week. But maybe you can propound your theory before we start.
Yeah,
with this,
I think I'll do that anyway, right? Okay. Yeah. So I've got 8 minutes. All right. So we'll be talking about the size of the universe, and the important thing to note here is that the reason why we have come to the conclusion that the universe is how big it is from our observations. Our observations are based in physics. Yeah. We've determined that sound, say you had like an emergency vehicle coming towards you, would drive past you and then drive down the road away from you. There's an effect called the Doppler effect, and you will hear it pitch up as it's coming towards you, like, and when it comes to you and you're in level with it, it pitches down. So, and then you hear this pitch down, and then as it leaves you, it actually pitches away, it pitches down, and that's the Doppler effect. So with something coming towards you, it pitches up, and when it leaves you, it pitches down. So, and pitch meaning the tone that you'll hear, that the sound, if it's continuous sound throughout from the observer, I'm the observer, but from the actual source of the emission of the sound, there isn't a change in frequency. Does it make sense? That's the Doppler effect. All right. So science, without being able to use any other method, it became convenient to examine the universe, and we noticed one thing, that the further away things looked, the redder they were. And that's close to it. So that's the observable universe. So that's with our naked eye. We can only see out to about Andromeda Galaxy. There isn't anything else that we can see with a naked eye that's further than that. But with telescopes, like leaving the camera aperture open for longer at nighttime, we can see more with telescopes that allow us to see further past there, but not very far. So the visible universe is like 13.5 billion light years. But to go further out to about 46, we have to use, say, the Hubble Ultra Deep Field, which was the enhancement to the Hubble telescope, or more. That's a visual telescope. And we can actually see a little further, but in infrared, we can see much further. So if on an electromagnetic scale of the EM spectrum, which is gamma rays all the way to, long waves in energy, it's only energy, it's just a measurement of energy, the human eye can only see a very small part, right, pretty much bang smack in the middle. Everything above visible light is actually harmful to humans, believe it or not, including UV light is harmful to humans. Everything below visible light is, I'm not going to say it's not harmful, but it's not going to destroy your DNA. And what science has discovered is that the further away things are, the more down the low end of that spectrum that they fall. So, applying what they knew about sound to light, and they've determined that they must be moving objects because they've applied the Doppler shift or red shifting as a Doppler effect, but on light, and there's no proof to suggest that everything's moving away from the Earth, and the further away you look, the faster they must be going because I applied the Doppler effect to light. Okay, so I've actually taken this up now. I've taken the cause under my arm and I'm running with this. And this is that applying the Doppler effect is actually incorrect because we had to derive a whole discussion around it to make it fit. Like, I don't know, the universe is expanding. But why is it expanding? Oh, because there's the Doppler effect. Well, how come you're using light and applying the Doppler effect to it? Or aren't you really what are you actually seeing here? And they said, well, the further away we look, the redder things get until they fall out of light and they go into infrared, and then they fall out of infrared into microwaves, and they fall out of microwaves into radio waves. And you go, okay, well, that's interesting. So my approach is that it is, in fact, not the Doppler effect we're seeing where everything's in motion or the universe is stretching, therefore the light appears to be making, acting in a way that appears to show motion, which is the universe actually stretching, but rather that light deteriorates over time. Everyone has suggested, because it's going to speed of light, the equation says that it's not experiencing any time. Really? Okay, sure. Why not? You can have that all you like. But if you say that maybe the equation is wrong, because the same thing happens, Meki gave me a great example. So say you build a spaceship and it's just a long hollow tube, but you're able to get that thing up to the speed of light, and then you build a spaceship inside that. But this spaceship we're traveling in is the width, like as a tube, as long as the width of our solar system. It's massive. So imagine inside there we build a little tiny spaceship that can also do the speed of light. What happens when it accelerates? The great argument. Well, our equations say that it's impossible. That means not even a human inside that spaceship walking at walking pace, which would equate to going faster than the speed of light. Not even that is possible. And that's preposterous. What a preposterous thing. Just because the equation zeroes out and doesn't let it happen doesn't mean it isn't possible. It's a fault in the equation, or the equation only reaches to there and then we need a new equation for the rest. Or this whole thing about, nothing can be faster than the speed of light is the problem. So what I've suggested is that light just deteriorates over time. Time is not irrelevant to light. It just happens to be the speed at which it travels, but it diminishes, and therefore as it diminishes, the wavelength stretches, and that's why we see things that are further away are redshifted, not because the universe is expanding or that everything is moving away and then we get this effect. The same thing was, the same argument can be used for the natural spin of objects in a galaxy. So if you have like a pinwheel spinning around, the things on the outside are going over greater distance on a pinwheel, of a painted pinwheel that you spin, and the things on the inside are going... Oh, don't tell me that's the music. Oh, my goodness. Anyway.
We're going to pick up next week exactly, in fact, earlier than this.
No, exactly the same time.
We'll get through.
We'll run out of time just like light degrades. We'll see you next week. Stay tuned for Jeb Bear. He's in the chat room. I can see him. He's got a great show called After Hours. Listen to that. This is David Mecki showing us out. We'll catch you next week. Take care.
Be safe.
Be safe and beware.